The objective started for students to design a launch device of their choice that could take a projectile and launch it a certain meter distance away. We chose about 25 meters, and our projectile was a water balloon. From there, we were able to look at two-dimension and vector problems within physics, and they were able to calculate X and Y components, resolve the vectors, and solve an initial velocity. So we were able to start with very basic foundations of two-dimension and vector problems. Then we were able to use those launches and discuss angled projectile motion.
With the project, it really actually comes out, it's kind of neat. It's STEAM component. You've got the science, you've got the physics, you got students, but then you've got that engineering and design component where it's not just a matter of giving out facts, it's also a matter of students learning through doing.
In our group, we decided to build a trebuchet, and our basic process was, she gave us the project. She was like, hey, build a launcher. There's no specifics, you just have to build something that can launch a water balloon. And she said, you can do whatever you want. So I walked up to my group and I was like, hey, let's build a trebuchet. They didn't know what a trebuchet was. So I had to kind of draw it out. So I made a little schematic of it. And then from that, we went down to Dr. Chrisman, grabbed basically all of his wood, and brought this up here. And we had someone else in the class named Dante. He's helped us build the entire thing. And right now, we're going through a process to build our arm, something that's going to be able to swing and throw the water balloon. So we're trying to figure out the best way that we can build the arm. And right now, we're going to need some notches on our arm so we can change the angle to see how much we have to throw, or how much power we have to have, and like what angle we need to use to throw the water balloon.
The difference between a catapult and a trebuchet is that a catapult uses a very tense string that once you let go of it, it's going to snap forward and launch a projectile. But a trebuchet is going to use a heavy weight to pull the arm upwards when you let go of the arm. So it'll fling them both about as much, but they have different methods.
Wow in the STEAM that we're doing is the design that the students are coming up with in general. The fact that one of our student groups came up with an air pressure gauge that could launch the water balloon, and it would actually use battery propelled air pressure gauge, and that they used a toilet paper rod in their design that could actually allow for the launcher to move at specific angles. I thought that was pretty cool and definitely a wow for me, because I've never seen, a couple of years doing this, a group do that before.
So in here, there's these air cannons, or these air canisters, and the air compressor right here pumps the air into them. And then whenever we're ready, once we get it up to whatever PSI we want, we just flip this lever into the open position, and it'll go through our other piece that I don't have. It'll go through the barrel and launch the water balloon using air pressure from all that.
Engineering is, they've been using drills. We've broken drill bits. We've actually had to cut the wood with multiple different ways with saws, and then we look at the art behind it. They've had to actually draw their systems with architectural scaled designs. They had to research the progression and the timeline of catapults, which could have led them to Da Vinci's catapult, which again brought in a little bit of the art objective. So we've got STEA, and the math behind it is obviously the calculations. They're working on fairly complex calculations with sine and cosine and tangent functions, and working with more algebra-based calculations, but kind of brings in the entire STEAM process.